Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we're looking at solving these radical equations, otherwise known as square roots and cube root equations. So let's go ahead, let's jump into these problems today. Whenever you have a radical, right, I see that my square root is right here. Anything that is on the outside of that square root, I need to move first. So for example, the 10 is not underneath it right now. I see that this 10 is adding with the square root, so why don't we subtract that 10 on both sides? That now gives me this equation. Well, I can't move the 2 or the 9 yet. The reason I'm not allowed to move either of those is they're underneath the radical. They are stuck under the square root right now. Well, this is a square root. We've talked about opposite operations, inverse operations. We know that the inverse or the opposite of a square root is squaring something, is raising it to the second power. Square roots and squares cancel. That gives me just 2x plus 9 now. On the other side, don't forget that you have to square both sides when you do that, just like when you subtracted 10 on both sides. That means the 3 is being squared, so I do need to perform that operation. 3 squared is a value of 9. Move stuff to the other side. At this point, it's just a two-step equation. We should feel comfortable with those. Move whatever adds or subtracts first generally, and then you can get rid of the multiplication or division second. That's usually a pretty safe strategy. In this case, we end up getting x equals 0. If you think back to the last video, we talked about these 1/2 powers and how 1/2 is really just the exact same thing as a root, where the root is a value of 2 and the exponent in this case is a value of 1. Do you have to rewrite it? No. Realize though these parentheses with the 1 on the inside are not needed because it's an exponent of 1. Square root, you don't necessarily need that 2 there either. When you have a 1/2 power, you might start just by rewriting it as a square root. Okay, now let's move stuff. Anything outside of the square root goes first, we said. Well, this -4, I need to move it. And a lot of people like to think add 4 over. But that's not right. The reason I'm not going to add 4 over is this is not 4 or the square root -4 or whatever. This is -4 directly next to the square root. Remember when things are next to each other in math. That means that they are multiplying. So to get rid of this multiplication, let's divide both sides by -4. That gives me 1 on the other side now, where it's equal to the square root of 2x minus 7. Notice the square root has not gone away yet, but now we can get rid of it. To get rid of a square root, we said we need to raise it to the same power on both sides. Square roots and squares cancel. So now 2x minus 7 equals 1 squared, which is just 1. Solve from here, add the 7 over, divide the 2 over, and it looks like we end up getting x equals 4. Let's look at another problem. This next one might seem a little bit trickier, but it's really this exact same logic. 1/3 power, though. Okay, well, we said that the 1/2 power is the same thing as a square root, so that would tell me that the 1/3 power is the exact same thing as a cube root. So let's rewrite this as a cube root now. Again, you don't need parentheses on the inside because you're just raising the 6x plus 4 to the first power. Okay, now we need to solve. Anything outside goes first. That 3 in the front needs to go first. That 3 is next to the root. It's multiplying. Okay, let's divide them. Let's divide by 3. Okay, the cube root is still there because all I did was get rid of the 3 out front. Now I can get rid of this root symbol. Okay, it's a cube root though. We knew that square roots and squares were opposite. A root and a second power were opposites. So if I have a cube root, I need to raise it to some power. More specifically, I need to cube it. I need to raise it to the third power. Whatever value you have for your root, that's the value you raise your problem to the power of. So now I have 6x plus 4 equals 64. Again, now that the root is gone, we should be okay solving from here, just performing our two steps. Subtract the 4, divide by 6. It looks like x equals 10 in this case. Those are different types of problems you might see. Here's a challenge problem. Okay? This challenge problem now already has the square root by itself. So, okay, I can get rid of that square root. I can still follow the same steps we did before where we square both sides. But when you square both sides in this case, you don't just have something raised to the second. In this case, we have two different items. We have the x and the 2 both being squared. Since they were both on that left side, they need to be in parentheses as they get squared. But now we need to think back. In order to square something, that means you multiply it by itself. So I'm taking x plus 2, and I'm multiplying it by another x plus 2. Okay, so x plus 2 times x plus 2. I know how to multiply that together. We talked this year about doing x times x plus 2, and the same thing with the 2. Again, do you need to show this step? No. There's a bunch of different ways to show the multiplication of parentheses. But now, let's go ahead, let's distribute that out. The x gets multiplied out, the 2 gets multiplied out. X times x would be x squared. Remember, you add your exponents when you multiply variables. X times 2 is 2x, and do the same thing with the 2 in the second set of parentheses. In order to solve this problem, though, we have a bunch of different x's. I have an x squared, a 2x, another x. And what I notice about those x's is they have varying exponents. Whenever you have multiple variables, and those variables have differing degrees, differing exponents, differing powers, what that means is you need to get everything to one side of the equation. Because you can't just isolate your variable anymore. Instead, you have to go about it by factoring. So I need to make this equation equal to 0. I subtract x, I subtract 8 on both sides, combine our like terms. The x squared is just by itself. That did not have any like terms. The 2x plus 2x minus 1x, all of those x's combine to 3. And the 4 and the negative 8 give us negative 4. This is a quadratic. We can factor it. Find two things that multiply to our a and c value. Find two things that add to our b value. In this case, those two values would be positive 4 and negative 1. So, okay, in this case, our a value is 1, so we are allowed to take our shortcut directly to the factored form, meaning I get x plus 4 and x minus 1 as our two factors. But in order to solve this, you would have to split it, set them both equal to 0, and solve. Subtract the 4 over, add the 1 over, and you get your two answers. One thing we have not talked about is what an extraneous solution is. We don't need to worry about it for right now. We're just going to go ahead and look at the solving process and call it good there. Realize, though, you do get an extraneous solution in one of these. An extraneous solution is a solution that arises when you're using an algebraic method. However, that value you found does not actually work in your equation. For example, if I were to plug in negative 4 into the original equation, that'd be negative 4 plus 2 and the square root of negative 4 plus 8. If I were to simplify both sides, I would end up getting this. Negative 4 plus 8 gives me the square root of 4. Square root of 4 is 2. However, on the other side, when I were to combine those two values, I got negative 2 instead. Those are not the same. That would mean that negative 4 is an extraneous solution and does not work. However, if you checked the value of 1, meaning I plug in 1 into this equation, 1 plus 8 is 9. The square root of 9 is 3. And on the other side, when I add those two values, it also gives me 3 here. That is a true statement. 1 is the true solution that happens in this process, where the negative 4 is extraneous. It does not actually work as a solution to this problem. That is it for our 6.6 video. Thank you for watching. Yeah, we just learned how to solve radical equations.